Hello, everyone. I'm Han, and this is the video explanation for homework 3, question number 1. So in this question, we're given a probability let's say pseudo probability function of this, and with k from 1 to infinite, and p smaller than 1, larger than 0 is a positive value, but smaller than 1. So the first part of it asks us to figure out what b is to make this function a probability mass function. So for this to be a probability mass function, this basically means that the summation of all the value, all the k value plugged in here, the summation of all that equals to 1. But there's no simple way to get that. So we do have the geometric sums equation like this, and it's a p over k, and for this p must be smaller than 1, larger than 0, and here it satisfies that. And we can take the derivative of both sides and get basically just take the derivative of over p on this side. It gets this equation k p to the k minus 1, and the other side is just this value is just a derivative of from here, and we know that b times this part is equal to 1. So basically we can just replace this part with this part and figure out what the value b is, and that's pretty much it for part A. And in part B, we should find ex, the expected value of x. Well, the expected value has the equation of this, which is written over here, and by plugging in all the all we had above, the b and the equation p k minus 1 times b, we get there's no easy way to figure this out either, but knowing that we have this part, we can because this is k minus 1, so if we delete this minus 1 or do a time a p outside, it gets to summation of, over k times p to the k, which is this part. Sorry, which is this part, which the p on the other side should also be a p, so the p is over here multiplied, and we can take the derivative of this part, this whole thing, left and right. After taking derivative, we have the k squared, which is needed over here. We also have p k minus 1, which is over here. Plugging b in. Oh, sorry, not plugging b in yet. We can just leave it like this, and the other side would be 1 plus p over 1 minus p cubed, which is simply a derivative of this over p. And keep in mind that this b is not differentiated at all. It should supposedly be outside here and not affected at all. So we can simply multiply the b over here without messing up with all the others, and plugging the b value that we obtained previously, we get expected value of x equal to 1 plus p over 1 minus p. And for part C, we should get the expected value of x squared, which, knowing that we get the expected value that the k square over here, basically what we need is a k cubed for expected value of x squared. We can do the same. We have the same reasoning like above. We can also which means that we also do derivative on the left hand side, but also times p before doing that. This side times p, which negates the k minus 1, just the k, and this part this side times p is just like this. Taking the derivative, we get this part. The right hand side is this, and the left hand side is the expected value of s squared without a b, and plugging b in, we get this value. And that's for part C. With part C's solution and part B's solution is for part D is really simple. Just do the subtraction. That's it. And let P equal to, the part E says that let P equal to 1/3. Find the conditional probability mass function. This px equal to kx smaller than 5, larger than equal to 2, smaller than equal to 5. Well, we can first analyze the conditional PMF to this, which is just like taking the normal conditional probability, just given this part, given B A is just PAB over PB, and the rest of the stuff is just plugging the values in. You know, P is given as 1/3, so plug in all the value 1/3 over here, because P is X equal to K is already given here. Just plug in the value, and for the upper part, also plug in the value. Know that this is only valid at, or there is a positive value at 2, 3, 4, 5, because x is less than 5, less than equal to 5, larger than equal to 2. So this should be if k is in one of these values, because it's a probability mass function. It's discrete, so it's just k equal to either one of these value. This is the equation for that, or 0, because k where k is not in these value. And that's everything for this question.